Hi, this is Dr. C, and I'm going to talk to you about the three dimensions of threading. So we have the ability to create threads and have threads do things concurrently as part of a process. But when we look at how threads are actually used in practice, there are three categories of use. First, independent workers. Second, sharing of data, when they share data, and the third is thread coordination. In a scale of complexity and potential problems, the simplest situation to deal with is using threads as independent workers. The other two, as we'll see in later lessons, have more complexities associated with them. But let's just assume that we want to have each thread do some independent work. Now, when we talk about independent work, we essentially mean that the threads don't have to share data. So they can operate on their own set of data, or they can go out and make network connections. But what we want to look at is how we can have a main program, and in fact a main thread, because every process has at least one thread, the main thread. But if our main thread launches three other threads to go do work, then we want the main thread to collect the efforts of that work in some way and then continue on. So the analogy I like to make is you drive to the store with your family getting ready for a party. You send different family members down different aisles of the store. They each pick up some different item, and they all converge at the end, jump back in the car, and drive home. So you're taking advantage of multiple workers, independent workers, and coordinating their effort. So here we see how this might be structured within a program. Let's say we have three threads, T1, T2, and T3. We start them off. They go and do some work, and then we want to print a message that says work has been done. Well, the reality of this little program is, if you think about it, how many threads do we have here? Actually, 4. We have the 3 that we launched, and then we have the thread that's actually executing the start and actually executing the print line done. What's going to happen here is the main thread is going to execute, most likely, before either T1, T2, or T3 have a chance to actually start their execution. So you're going to see done printed before any of the threads do their work. So we don't want that situation. We want to have our main thread wait for the other 3 threads to finish. So let's see how we can do that. Now, to have the main thread wait for other threads to finish, we use the join construct. So where you see T1.join, the main thread is executing this statement and basically says, block me, take me out of the runnable pool until T1 is no longer active, until T1 is dead. So when T1's run method finishes, then the main thread will be released from the non-runnable state, move back into the runnable state, and will presumably continue. Now, the next thing it does upon waking up is it looks and says T2 join. So if T2 has already completed and thread T2 is dead, then the main thread can continue. But if T2 is still active, the main thread will block until T2 finishes. When T2 finishes, we then go down to T3 join, and if T3 can either be finished or not finished, but we are here guaranteed that we will not see system out print line done occur until after all threads have completed their work. And so this is an example of how you can partition work among different threads and hang around and wait for them to complete before you go off and do something.